Hello everyone, welcome to my channel. In this series, I would like to demonstrate those most frequently asked questions in A-level math exams. And in this particular video, I'd like to show you this topic about probability and distributions, well, more specifically, discrete random variables. Okay. So I think before we get started, I'd like to talk about what is discrete random variables or distributions, discrete RVs. So discrete means that there are countable, usually countable like finite or countably finite, and variables, like in this case, you can see 10, 20, 30, 40, and 50, 5 of them countable, yep. And you can say each of the events, and for each event, we would like to assign a probability to the event, okay. And the most important thing is there are events, there's a probability, and all the probabilities sum up to 100, sum up to 1, okay. And those events that not appeared here, say D is 0, well, it's probability 0 because it's not one of our events, okay. So it's basically, if you want to formally speaking, probability distribution is a function that assigns probabilities to each event, okay. And now let's get started. The discrete random variable D has the following probability distribution. When D is, okay, when capital D is little d, and you can see the probability is k over 10, k over 20, k over 30, k over 40, k over 50, where k is a constant. And part A, show that the value of k is 600 over 137. So what do you think might be helpful here? I think the first thing to do here, because you can see all the probabilities are unknown, but they are kind of linear to each other because they're some multiple of there's some multiple of k, right? And using the fact that the sum of all the probabilities of all the events, okay, sum, let's say events to be denoted by I, and the indexing says I, the P, I, X is I, should be 1, right? As I just stated. This is generally true for any discrete random variable. So using that formula, we have k over 10 plus k over 20 plus k over 30 plus k over 40 plus k over 50 is 600 over 137. Oh, sorry, that's 1. And what do you think might be helpful here? Because we're summing all those fractions, either we're going to put them under a common denominator. In this case, it will probably be 30 times 3 times 4 times 50. Should be about, the common denominator should be about 600. Yeah, let's just times 600 on both sides and see what happens. So now we're going to have 60k plus 30k plus 20k plus 60 over 4. Damn, it's not divisible, is it? I don't think it's divisible, but it should be 60 over 40, 60 over 4, 30 over 2, 15. It's 15k. Okay, it's 15k. And plus 12k, I believe, equal to 600. Summing all those together, we have 90, 110, 125, 126, sorry, 130. Yeah, 137k is 600. So k is 600 over 137 as required. Okay. Now moving on, the random variable d1 and d2 are independent and each have the same distribution as d. That means p d1 equals to some particular little d is as expected here. Okay. And part B, find the probability that d1 plus d2 is 80. Giving your answer to 3 sig figs, 3 mark. Well, you might wonder what does it actually mean. Well, that basically means that how many combinations of D1 and D2 gives sum up to 80? Easy one. Let's say D1 is 50 and D1 is 50, D2 is 30. Could be one, yep, because 50 plus 30 is 80. What about D1 is 40, then D2 is 40. And then D1 is 30, D2 is 50. Right, all of those combinations give us sum that to 80. But I would say that there's all the combinations possible, because if any one of the random variables takes value at 10 or 20, the other counterparts should take values of 6 and 70, which is not covered in our distribution, and hence the probability of such event is 0, and they basically means that do not exist. Okay, that's not happening. So the only possible random variables, the distributions, could be D1 is 80, 30, 50, 30, 40, 40, 30, and 50. There are only 3 of them. Okay. Now let's find the individual probability that what's the probability that D1 is 50 and D2 is 30. One of the most important information here is that D1 and D2 are independent. That means P D1 is like I1 intersection with D2 is I2. It's basically the probability of D1, not P1, equals to I1 multiply with probability of D2 equals to I2. Always remember, independence implies multiplication. We're allowed to do the multiplication here. We're allowed to do the multiplication here. So in this very particular case, PD1 is 50 and D2 is 30 is exactly PD1 is 50 times PD2 is 30. So basically, K over 50 times K over 30, we shall have 600 over 137 over squared times 1 over 50 times 1 over 30. That should be 20 times 12 over 137 squared. Okay. And you can see by similar argument here, the probability that D1 is 30, D2 is 50 is the same, okay? And now what 40 and 40? You can see that's basically PD1 is 40, which is 600 over 137 times 1 over 40 squared, and that would be 15 squared over 137 squared. So all the probabilities, total probability of these 3 events happening is twice of 20 times 12 over 137 squared plus 15 squared over 137 squared. Let's just type it into a calculator. And you should roughly have the probability is 0.0376 roughly. Okay. A single observation of D is made. The value obtained, little d, is a common difference of an arithmetic sequence. Interesting. The first 4 terms of this arithmetic sequence are the angles, measured in degrees, of a quadrilateral Q. Find the exact probability that the smallest angle of Q is more than 50. Interesting. You probably want to understand this information for a while, because it's a bit tricky. So let's say the smallest angle is alpha, then this alpha plus d, alpha plus 2d, and alpha plus 3d is the out of 4 angles of some quadrilateral, isn't it? Quadrilateral Q, okay. And for any quadrilateral, we know that their internal angles sum up to 360. So that means when we sum all these things together, we should have 360, which is 4 alpha plus 6d, okay? where alpha is the smallest angle, which we don't know, but we want it to be greater than 50. Okay, so the information given here is 4 alpha plus 6d is 360, and alpha is hence 360 minus 6d over 4, which is 90 minus 3 over 2d. Now let's just substitute the d's inside. So now let's just try with all the values of d possible. So first one, say d is 50. That implies alpha is 90 minus 3 over 2 times 50, which is 90 minus 3 times 25, so 15, which is less than 50. No good. Next one, d is 40. Then gives alpha is 90 minus 3 over 2 times 40, which is 90 minus 60, and that is 30, still less than 50. And next one, this 30, which implies alpha is 90 minus 3 over 2 times 30, that 3 times 15, which is 45, and again that's 45, which is still less than 50. And you can see, it seems like it's increasing by 15 each time, so you probably would expect next one to be 60. I don't know, I think it should be, right? Let's say d is 20, and then alpha is 90 minus 3 over 2 times 20, which is indeed 60, which is greater than 50. Good. And you probably expect d is 10 should also satisfy and should give you 75. Let's just try. Yep, 90 minus 3 times 5, that's indeed 75. So, little d is either 20 or 10, and the probability that d is 20 or 10 is basically p d equivalent to 20 sum p d equivalent to 10. Right? This is a law of addition of probabilities, because for two distinct events, their unions is basically the sum of the separate probability. Okay. So let's just do k over 10 plus k over 20, which is 600 over, well, which is 600 over 137 times 1 over 10 plus 1 over 20. So 60 over 137 plus 30 over 137, so 90 over 137 is your required probability. Does it say? No, it doesn't. Exact probability, so let's just keep it in this form of fractions. Now let's just summarize for this question. Okay, quite an interesting question because it's actually examined on lots of different concepts for this question. So the first part, what's the most important thing for you to remember is this formula here, that the sum of all the possible events, their probabilities, gives to 1, okay? This is the only thing we used in part A, right? Because if you don't know the facts, you have no way to calculate what the k is, and if you know it, you can just equate a very simple equation. And using some basic math, summing fractions and moving things around, you can easily get k is 600 over 137. And for part B, well, there are quite a few things. So first of all, you need to really understand what is d1 plus d2. It's basically like choosing two realization of the random variable d. And then we need to find some particular combination of the realizations such that the first one is summing the second one is 80. And there is no systematic way to just quickly say, oh, I can calculate from here. No, we can't. We need to calculate, so we need to count all the possibility by brute force. i.e. by examining, like, how can you split 80 into 10, 20, 30, 40, and 80? And you can see it's only 3 here. 80 plus 30, 30 plus 50, sorry, 50 plus 30, 50 plus 30, 40 plus 40. And you may ask why there's only one 40 plus 40, because there's only one 40. And on any other summations, you can have twice, because choosing d1 to be 50 and then d2 to be 30 is the same as choosing d1 to be 30 then d2 to be 50. Because because we have another important property here, that such two realizations are independent. Okay, that means whatever you do for D1, D2 is going to follow the same distributions. Okay, and the most important thing is independence implies multiplication. That means when you find some intersection of the two events, we just multiply the individual probabilities. Okay, and you can say it's not too hard. You just need to read the question really carefully, like catch every keywords, every key properties that could be helpful to it. And the follow procedure will be fine. The last part is quite tricky. First of all, you need to really understand what this operation is doing, because it introduces quite a lot of things. What is my arithmetic sequence? Arithmetic sequence, you should be familiar with. They are the sequence where the common difference between two consecutive terms is a constant. Okay, the common difference is constant, not common ratio. That was geometric. And for arithmetic sequences, we'll always love to we'll like to investigate how they sum up to. In this case, we like to sum up the first four terms, not angles. Obviously, they are angles, but in this particular question, they give the terms some specific values, or specific meanings, actually. And you can see, well, the first term is alpha, second term is alpha plus d, third term is alpha 2d, and alpha plus 3d. From this logic, you can tell that they are actually the separate internal angles for our quadrilateral Q. And another important property here is that the quadrilaterals have internal angles somewhere to 360. You can see there are loads of information hidden behind the part C, and loads of other other knowledge from other sections of the course, right? In fact, the internal angle from quadrilateral is actually GCSE, but you might not to think about it at instantly when you see this question. Right? But other than that, you can see, if you realize what's the relationship between alpha and your smallest angle d, the common difference d, you give the formula here, where alpha is 90 minus 3/2 times d, and gives you quickly to calculate all the possible values of alpha given all the 5 possibilities of d. And just verify them by brute force. It should cause no difficulties in doing so. But the only tricky part is, how do we understand that? How do we catch all the informations and utilizing all the informations, applying the correct theorems or knowledge you have learned in textbooks? I think the most important part is still down to practice, because you can't read the books to understand the knowledge. You can't just have a look at the proof and then know this is how the theorem works. You really need to apply it, examine it, and practice it by those questions. Okay? So I recommend you, and as always said, practice makes perfect. After this video, I would really like to find some similar questions and have a try, and probably be inspired by the whole logic and the solution. And thank you for watching. See you next video.